All right, so we're continuing in our study of exponents and the laws of exponents, and we're reaching our final few, and really these particular power rules or laws of exponents are kind of the same thing. We're allowed to, they're telling us that basically anytime you take a term and you take it to a power, right, the whole term gets taken to a power, the effect is that we multiply the exponents. Okay, so it could look like here at power of a power, where right, we have a single term like a to the m power, and then we take that whole thing, right, to the p power. So what we do is we end up multiplying m times p. We're multiplying our two exponents together. Okay. Here, right, we're doing the same thing, except we have an understood 1 and an understood 1 here. So we're multiplying 1 times m on both of those. So it's really the same rule. It looks a little different. Okay. And then if we were dividing, right, that's where we get the word quotient, right, versus here where we have product. Okay, so the quotient, we're dividing A divided by B, so we can split that apart and just kind of like distribute that m to both of them. So this is A to the first, and this is B to the first. So 1 times m is m, 1 times m is m, and that seems to be a typo. That should be B right there. So if you were confused as to why that was A, you might want to go ahead and change that to a B. That shouldn't have been there. All right, so we can combine and use these properties to simplify expressions involving monomials. All right, so we're going to start off here, and we see that each of these members of the term, right, -2 has an exponent of 1, A has an exponent of 1, B has an exponent of 2. Then we have this 3 on the outside, so we're going to multiply that 3 times 1 times 1 times 2. So we're going to end up with -2 to the third power, right, because 1 times 3 is 3. We're going to have A to the third power, again, because 1 times 3 is 3. And we're going to have B to the sixth power, because 3 times 2 is 6. Okay. Now, we can take this -2 to the third power and actually come up with the numeric value of that. That means -2 times -2 times -2, which is -8. Okay, so that's that first term simplified. Right? Now we're going to look at the second term, a squared times to the fourth power. Okay, so it's just one term with one exponent. So we simply multiply these two numbers together and we get 8. Okay, so we're going to have times a to the 8th. Now we're through with our new power rules, but we have two a terms and we're multiplying. And we learned yesterday when you're multiplying like bases, you can add their exponents. So we're going to add 3 and 8. And then the -8 and b don't have any like terms, so we're just going to bring those down. So now that is -8, a to the 11th, b to the 6th power. Okay. All right, let's take a look at some other uses. All right, so here, right, I just have y to the 5th inside the parentheses, and it's going to the second power. So that tells me I can multiply these two powers together, and I'll have my the relationship. Now some of you may be wondering, why are we multiplying these powers together? That doesn't make any sense. I don't get that. Okay, so let me just kind of break it down. Y to the 5th to the second power means y to the 5th times y to the 5th. Okay? And we know from our rule yesterday that most of y'all got pretty easily is when we multiply like bases, we add the exponents. So 5 plus 5 is 10. So that equals y to the 10th power. Okay? But it would have been a shortcut right here if we just said 5 times 2 which equals 10. And we could have gone straight to y to the 10th power. Okay. So, and then the same here, right? We've got to the third power for this parenthesis. So we're saying take ab to the fourth power, and we could literally write it 3 times. We could say -3 times ab to the fourth times ab to the fourth times ab to the fourth. And then we know these are all 1s, so how many 1s do I have? 1, 2, 3. How many 4s do I have? I have 3. Well, repeated addition is our multiplication that we were going to do here if we followed the rule. Okay, so I would not probably expand this all the way out. Okay, what I would do is I would use my rule that says I can multiply this power times the other powers inside the parentheses. So that would be -3, right, a to the third, b to the 12th. The -3 doesn't get this 3, right? Okay. Now if we look over here, the -3 is inside the parentheses. So this one's going to be a little bit different, right? This 3 is going to go to all of these numbers. And I'm not going to have -3 anymore. I'm going to have -3 to the third power. So that's going to change up my answer. But I'm going to let you come up with that one. Okay. Here, right, we have x squared to the 5th power. And we can totally see that that's our power rule in play. We can multiply these two numbers together. We have x to the 10th times x to the 3rd. And then we know that we have like bases, so we can add these exponents together. 10 plus 3 is 13. Okay. All right. Let's see what else we've got. Okay. All right. Since y'all tell me I never work out the hard ones with you, right? I always give you the easy examples, and then you get complicated on the work. I'm going to take on this number 13, because that's got fractions and powers, double powers, right? Powers all over the place. Okay, so we're going to take this into pieces. We're going to look at this first term here, okay, and then we're going to look at the second one, and then we're going to try and put them together. All right, so this means 25 to the 3rd power now, because I had a 1. 3 times 1 is 3. A squared to the 3rd power means a times to the 2 times 3, which is 6. And then that b has an understood 1 is its exponent, so 3 times 1 is 3. So that's the first term. Now we look here, we have 1/5 to the 1st power, a to the 1st power, b to the 1st power, f to the 1st power. Okay, so all of these, if we multiply 1 times 2, we're going to get 2. So that's going to be 1/5 to the 2nd power, a to the 2nd power, b to the 2nd power, and f to the 2nd power. Okay. So now for 25 to the 3rd power and 1/5 to the 2nd power, I can go to my calculator if I need to. Okay, and 25 to the 3rd power means 25 times 25 times 25. Okay, 1/5 squared means 1/5 times 1/5. And I'm going to tell you, I went to my calculator and I typed in 25 to the 3rd power times 1/5 to the 2nd power, because I remembered from our work yesterday, what are we going to do? We're going to take the front number, right, the coefficient from each one, and we're going to actually multiply those two together. Okay, so when I did that, these two became 625. Okay. All right, then I look and I see I have an A term and another A term. We're multiplying. I know we're multiplying because before we had the parentheses, right? So we're multiplying these things together. So I'm going to add the exponents. 6 plus 2 is 8. So that will be A to the 8th. And then 3 plus 2 more makes 5, so b to the 5th. And then I don't have an f here, I just have this one f there, so f squared. Okay, so I'm going to write that just above that final answer because it's kind of bleeding in there. So that's 625 a to the 8th, b to the 5th, f to the 2nd power. Okay. All right, let's take a look down here towards the bottom. We're getting some kind of unusual looking stuff. This -2 power, we didn't have any negative powers, right? On the up here, they were all positive powers. So let's take a look at that. Okay. So if we have a negative power, we saw yet a previous lesson that a negative power, to get rid of the negative, we do the reciprocal. So if we take the reciprocal of in here, right, that would become 3x to the 4th y z to the -2 over 2x to the 3rd y squared z, right? And that's now to the +2 power. Okay. Similarly, I could start taking care of the negatives inside, but we talked about that before when we're doing division. A lot of the times the negatives will take care of themselves, so I usually just want to wait till the end to take care of the negatives with division. Okay. So we want to clean up inside the parentheses because order of operations says we do what's inside the parentheses before we take care of exponents. So I'm noticing the division here, and I'm also noticing I've got y and z. They don't have an exponent, so I'm going to put that 1 in there. Okay, division, our rule for division was that we would subtract the exponents. So that would be x to the 4 minus 3, y to the 1 minus 2, z to the -2 minus 1, and then we just have 3 over 2, okay, and then when I do my subtraction, 4 take away 3 is 1, so that's just going to be x, so the 3, okay, 4 take away 3 was 1, 1 take away 2 was -1, and -2 take away 1 is -3. Okay, and still over 2. All right. Oh yeah, and I almost forgot, I still got this power of 2 on the outside, right? I haven't taken care of that yet at all. Okay, so negative exponents can be brought below, so to speak, because we do the reciprocal. So these would come down, and I would have 3x over 2yz to the 3rd, and then all of that's to the 2nd power. Okay? So that means we're going to do 3 to the 2nd power, x to the 2nd power, 2 to the 2nd power, y to the 2nd power, and then z to the 6th power. Okay, because remember, I'm multiplying 2 times 1 times 1 times 1 times 1, and then times 3. Okay, so 3 to the 2nd power is 9, so I have 9x squared. 2 to the 2nd power is 4, so then 4y squared z6. And that is my final answer. Whew, that was a lot. Okay, so let's kind of go back over that just one more time because that was a lot of stuff going on. We got rid of the negative exponent on the outside by making the reciprocal of what was inside. Right? The reciprocal is the flip of that fraction. Okay. Then once we did the flip, we simplified what was inside the parentheses. Then we distributed our 2 exponent. Okay. And then we finally simplified our numbers, 3 squared and 2 squared. Okay, now there is another way you can do this. Instead of taking care of the -2 to begin with, we could have left it -2, done the simplifying. So how that would, or we could have distributed the -2 to at the very, very beginning to everything, and then simplified to get rid of any negatives that were left. So how would that have looked? That would look something like on this one, right? We have the understood 1 powers right there and there. So this becomes negative 2 to the negative 3, m to the negative 3, n to the negative 6, right? And then we still have 4, m to the negative 6, n to the 4th. Okay? So negative 2 to the negative 3rd power, right, means we need to bring this entire term down below to get rid of the negative. Okay, so that would be negative 2 now to the 3rd power times 4. Okay. M to the negative 3 would come down below and become m to the positive 3. M to the negative 6 would need to go up. N to the 4th would stay put because it's a positive exponent, and n to the negative 6 would come down and be n to the positive 6. Okay. So now we're almost there. We can go ahead and pop that in our calculator and multiply. And negative 2 to the 3rd power is negative 8 times 4 would be negative 32. So we're going to have, I'm just going to draw my line, and we'd have negative 32 down below. Okay. Then 6 take away 3 is 3, so m to the 3rd. And 4 plus 6, because we're multiplying, even though we're down below, right, we're multiplying these two together, that's going to be n to the 10th. So final answer, m to the 3rd over negative 32, n to the 10th. All right, that should give you all something to work with, and I expect y'all to get busy on your work and ask questions if you have them.